Question says, find all minors and cofactors of a 3x3 matrix. So let us begin this process. Remember the definition. If you have a square matrix, then the minor M sub ij of entry A sub ij is the determinant of the matrix obtained by deleting the ith row and jth column. So if you're finding M sub 1 and 1, you have to delete the first row and the first column. If you're finding M of 1 and 2, you have to delete the first row and the second column, and so on. Then the cofactor by definition is C sub I and j, which is -1 to power I plus j. So whatever your I and j is, it becomes the summation on the power of -1 times the minor for I and j. So let us begin. What is M sub 1 and 1? What's the minor for the first row and first column? So this is the matrix. Since it's first column and first row and first column, so you have to delete the first row and the first column. You're left with 2x2 matrix. The determinant of this 2x2 matrix, as you remember, is 5 times 1 minus 6 times -3. So it is 23. We found the minor for the first row and first column. Now, what is the minor for the first row and the second column? Copy down the matrix, delete the first row and the second column. You end up with a 2x2 matrix, and the determinant is 4 times 1 minus 2 times 6, which is -8. Now, let us calculate the minor for the first row and the third column. So first row is deleted now. The third column is deleted now. You end up with a 2x2 matrix. What is the determinant of this 2x2 matrix? -3 times 4 minus 2 times 5, which is -22. We have more minors to calculate. So this is just the very first slide, calculating the minors for the first row, first column, the minor for the first row, second column, the minor for the first row and third column. Here we go. So we copy down the matrix again. Now we are finding the minor for the second row and first column. It means that I'm getting rid of the second row and the first column. I end up with a 2x2 matrix. The determinant of this 2x2 matrix is 2 times 1 minus 1 times -3, which is 5. Now let us calculate the minor for the second row, second column. So you're deleting the second row, the second column. You end up with this 2x2 matrix. You need to calculate the determinant here. You multiply 1 and -3 minus the multiplication of 1 and 2, which is -5. The next minor is related to the second row and third column. So M sub 2, 3 is related to the second row and the third column. By deleting these, you get a 2x2 matrix, and the minor is the determinant of this 2x2 matrix. We're going to multiply -3 by -3 and do the subtraction 4. You get 9 minus 4, which is 5. Now we're going to move on to next minor for the third row and first column. So you're deleting the third row and the first column. You have a 2x2 matrix, and you're finding the determinant of this 2x2 matrix. 2 times 6 minus 1 times 5, which is 7. Again, we are working with this 3x3 matrix to find the minors. The next minor is for the third row and the second column. We're going to delete the third row and the second column. We end up with this 2x2 matrix. The determinant of this 2x2 matrix is -3 times 6 minus 1 times 4, which is -22. Copy down the original matrix again. Find the minor for the third row and third column. So as you remember, it is denoted by m sub 3 and 3. By deleting the third row and the third column, you end up with this 2 by 2 matrix, and the determinant is negative 3 times 5 minus 8, which is negative 23. Now that we calculated all of these minors, we are ready to find cofactors. So remember the definition of cofactor. C sub I and j is equal to negative 1 to power I plus j times m sub ij. Remember, m sub 1 and 1, or the minor for the first row, first column, was 23. You can use this to calculate C sub 1 and 1, which is by definition negative 1 to power 1 plus 1, which is 2, times the minor for the first row, first column. But this is just 1. You already know that your minor is 23. So 23 times 1 is just 23. Now for the second minor, m sub 1 and 2, as we saw, is negative 8. You can easily use that to calculate C sub 1 and 2. By definition, is negative 1 to power 1 plus 2, which is 3, times the minor for the first row and second column. Since it's negative 8 times negative 1 gives you positive 8. Now for the minor for the first row and the third column, you got negative 22. We're going to use that to calculate the cofactor for the first row and the third column, which is negative 1 to power 1 plus 3, which is 4, times the minor for the first row and third column. But negative 1 to power 4 is 1. Multiplied by negative 22 gives you negative 22. By using each minor, we can find each cofactor. So let us go to the next set. We did the computation for the minor for the second row, first column, second row, second column, second row, third column. We're going to use these to find the cofactors. The cofactor for the second row and the first column is going to be negative 1 to power 2 plus 1, which is 3, times the minor related to the second row and first column. But take a look. The minor that you calculated for the second row, first column is just 5. Here you have negative 1 raised to power 3, which is negative 1 times 5 gives you negative 5. Now let us take a look at the minor for the second row and second column. This is equals to negative 5. We're going to use this to calculate the cofactor for the second row and second column, which is negative 1 to power 2 plus 2, which is 4, times the minor for the second row, second column that you calculated as negative 5. But negative 5 times 1 is negative 5. We calculated the minor for the second row and the third column, which is 5. Now we're going to use this to calculate the cofactor for the second row and the third column. By definition, it's equal to negative 1 to power 2 plus 3, which is 5, times the minor for the second row, third column. Negative 1 to power 5 is negative 1. Negative 1 times 5 gives you negative 5. So far we had 6 minors. We calculated 6 cofactors. Let us move on to the last set. We did calculation for the minor for the third row and the first column, which was 7. We're going to use this to do the computation for the cofactor for the third row and first column. The cofactor for the third row and first column is negative 1 to power 3 plus 1, which is 4, multiplied by the minor 3 and 1. So take a look. Here you have a 7. 7 times 1 is 7. Now let us move on to the minor for the third row and the second column, which by calculation, it is -22. Now, what is the cofactor for the third row and the second column? By definition, it is -1 to power 3 plus 2, which is 5, times the minor for the third row and second column. Since it is -22, -22 times -1 to power 5 is -1, is equal to +22. And finally, the minor for the third row, third column, we did the calculation and it is -23. We're going to use that to calculate the cofactor for the third row, third column. By definition, it is -1 to power 3 plus 3, which is 6, times the minor for the third row, third column, which is -23. -23 times 1 is -23. So these are all the steps how to calculate the minors and cofactors for a 3 by 3 matrix.